Yeah, very good evening to all. Very good evening to all. Welcome to day 11 of my masterclass. So, very good evening to all. Thank you for joining. Thank you for your presence in the masterclass. Today's day 11. Today we are gonna see the FSM Mealy. Yeah, I'm doing well. So, good evening to all. Good evening, Akshay. Good evening, Kalyani. Good evening, Masbai. Very good evening. Let's wait for a few minutes. So there are less members in the live, so we have to wait for remaining people have to join. So yesterday we seen like FSM more. So how to write the code for the FSM more type overlapping and non-overlapping. So today also we are gonna see FSM Mealy, how to write FSM code for FSM Mealy. So we'll try to write the overlapping and non-overlapping of the Mealy type. So good evening to all. So today in this session we will go to write the article code, and also we try to understand the state machines. So state machines of the FSM Mealy type. So yeah, you can also eligible for the course, so you will get also e-certificate. So don't worry about that. You will get also certificate you can use for course in your institute. So you are eligible for the e-certificate. Just you have to put attendance correctly. So you have to maintain the 70% of attendance in the 2020 master class. Then only you can able to receive the e-certificate from this master class. So very good evening to all. Thank you for joining. So let's get into session. So today we are going to see FSM Mealy. So and then we'll try. We know that what is FSM, and we already seen that Mealy and Moore type difference between the Mealy and Moore. So today we are going to see Mealy. So firstly, I'm going to write the code for 0111 sequence to find the sequence of the 0111. So let's start with state diagram. So this is the state diagram for non-overlapping sequence detection of 0111 by using the Mealy. Yeah, very good evening to all. Lakshmi, Anthony, Pavitra, John Paul. So very good evening. Thank you for joining. So this is sequence detection we are going to see in this session, and then the sequence is 0111. So this is a sequence I have to detect from the input sequence by using the Mealy machine, Mealy FSM. So it has two types. You already know that non-overlapping and overlapping. So study also we seen that overlapping, non-overlapping of the Mealy type, more type FSM. Today we are going to see Mealy type. So Mealy machines needs only 4 state only. So more machines needs additional of one state to give the output, but in Mealy it need only 4 states. So 4 state means how many bits in your sequence it is equal to your state. So I'm having the 4 bit of sequence detection. So this sequence I have to detect from the input sequence. It has 4 bits. It has 4 bits. So I need only 4 state only. So you can see here S0, S1, S2, S3. So this is my states. So this is my states S0, S1, S2, S3. So I want to transit from one state to another state based on my input. And then one more thing, the Mealy FSM machine has a output in the state itself. So you can see in the diagram every state having output. But in the Mealy machine, you will get the output at the transition of the state. So if I move to, you can see, you can see here 1 by 0, 0 by 0, 1 by 1, 0 by 0. This means this is refers to this. Numerator is refers to input. This 0 is refers to output. Numerator refers to input, and then denominator is refers to output. So in the Mealy machine, so there is a states. So if it is input, if my input of the first this particular state, if you take in a state, so I want to detect this sequence. If it is input is 1 means it will stay in the same state. If it is our input is 1 means it will move to next state, but my output is 0. Why? Because of at the final state or last state of the FSM only I will get my output. So you can see here 1 by 1. So this one is refers to I got my sequence. I successfully detected the sequence. So I can represent that by using this one like a 1 by 1. So this is a way of this is a basic for Mealy machine, FSM state machine. So it has 4 state. So output of the state, output of the sequence or FSM can be known by the transitions. So you can see here there is no separate state for the there is no separate state to know the output. So in Mealy machine we have the additional output like S4. So from that S4 state only we are finding my output. So if the S4 state is 1 means we can say this I got my output. But in but in the Mealy machine it will give output in the transition of the states. So let's see how it is work. So you can see here numerator is refers to input, denominator is refers to output. So I have 4 state. So if you take from one state, so in the this is my first state S0, my input is 1 means it will stay in the same state. Why? Because of if I want to move to next state means I want to receive input as 0, then only I can move to the next state. So if my input is 0 means I will go to the S1 state, but here it's you can see 0 by 0. It means my input is 0, but I out then here is 0. It refers to output is 0. Why it is 0 means I didn't get my sequence. Only if I get my sequence means it will change to 1 here. If I change to 1 means I got my output, like I got my sequence. So only if I got my sequence only I can denote as 1 in the output. So in the S1 state, so this S1 state, so in the S1 state it has 0 value, it will store the 0 value. And then in the S1 state, if input is 0 means it will stay in the same state. Why? Because of already it having 0 value. So you can see here the 0 it having. So if the input is 0 means there is no necessary to go to initial state. So S0 state, you can stay in the same state. So this is a reason why it is stay in this stay in the same state. Already it having 0 value, it store the 0. So it can if input is 0 means it can stay in the same state. And then if it is 1 means it will move to the S2 state. You can see if input is 1 it will move to the S2 state, and the time my output is 0, so I didn't get my sequence, so my output is 0. So this is S1, this is for S1 state. In the S2 state, if it is 0 means it will move to the, we can see my input is 0 means it will move to the S1 state. So why? Because of S1 we already know that S1 state having 0, it stores a 0 value from the S0 state. So it will move to the S1 state. If it is 1 means input is 1 means it will move to the next state, S3 state. So in the S3 state it stores 0 1 1. In the S2 state it stores 0 1 only. So if it is if the input of S3 state is 0 means it will move to the 0th state. you can see here it will move to this 0 state. Why? Because of the state it having 0, sorry, s1 state. If it is input, if the in the s3 state, if the input is 0 means it will move to the s1 state. So why? Because of s1 state will s1 state it store the 0, that's why it will move to s1 state. If it is 1 means we got 0 1 1, already we got 0 1 1 in the s3 state, and then if you in the s3 state input is 1 means I got my sequence like a 0 1 1 1. So I can go to, if I after I got sequence, I will it will change 1 here. So in the denominator it will change 1 here. It means it refers the output I got my sequence. So I can refer, I can give 1 here. It means I got my sequence. I successfully find the sequence from my input sequence. So it is refers to I got my sequence outputs. So I got detected the sequence correctly. So, and you can see here it will go to the initial state. So here if a input is 1 means it will store it will stay in the same state. So if it is goes to initial state means we can say this is a non-overlapping state machines. Why? Because of after the sequence detection it is start from the beginning, so it will move to the initial state. So if it is goes to initial state s0 state means we can say this is a non-overlapping. So and then so this is a state diagram for the FSM 001 Mealy machine for non-overlapping. So and then we'll move to the sorry, I have to change something. Here we can see the overlapping. So this is the state transition of the overlapping. So the main difference is s3 state. If it is 1 means it will go to the if it is goes to the s0 state means we can say this is a non-overlapping. But if it is goes to second state or stay in the s3 state means we can say this is a overlapping. Why? Because of we know that overlapping means it can use previous state values. So this one is refers to I got my sequence in the s3 state. So next I will go to the initial state means it is a non-overlapping, but I am going to the previous sequence second state. So why? Because of already it having 0 1, so there is another chance to get 1 here. So it will go to s2 state. So it is a overlapping. Or we can, and our s3 state already it having 0 1 1, so it can stay in the same state. It means if it is stay in the same state means we can also using the overlapping. So it is also using the previous values, so previous sequence outputs. So it use the previous sequence, so we can say this is a overlapping. So this is the difference between the both overlapping and non-overlapping. Overlapping means it will move to the some part of the sequence like s1 s2 like this, or s3. If it is moved to the after successfully detection the sequence, it will move to the initial state means this is non-overlapping. If it is moves to some part of sequence means we can say this is overlapping. So there is a difference between both of them. And then so if you guys are really interested, you can convert this 1 month 21 day masterclass into 1 month internship program. So internship on FEJ design. So these are the benefits you will get at the 1 month internship program. All 30 days recording session, all 30 days presentation, exclusive project codes, VAB community group for your doubt clearing and the internship updates. So you will get the internship confirmation letter from IETE, and you will get the 90 days LMS course access. So and you will get also assignments and tasks, and you will get the weekly live session, and resume building ideas, top mock test, and finally you will get the internship certificate and also participation certificate in the 1 month of internship program. It just all around just 999 only at the discounted fee of just 999. So our regular fee is 3999. So in this session period we are providing our internship program just discounted fee of 999. So by using this registration link you can avail it. So this offer will close at 22 March. So this is a limited time period offer. So if you guys are really interested, you can join our internship program. So let's move to coding part. So we'll try to write the code for 101 sequence. So I just first I'm going to write I'm going to write both Mealy overlapping and non-overlapping in single code. Yesterday we also seen like same thing also. So I'm using one control signal. If it is high means it will do overlapping. If it is low means it will do non-overlapping. So same sign. So same thing. So I'm going to use today also. In the single code I'm going to write this FSM Mealy machine. And in this more you will get the certificate. We will provide you. So let's get into code. So my sequence is 011. My direction is Mealy machine. I'm using Mealy machine. So same logic yesterday we also seen. Same logic. But here is a one advantage, we have to use only 4 state, not a 5 state. So module, my module name is FSM underscore 011. So this is my module name. My port list. So in the port list I'm declaring my input output signals. My input signals is firstly clock and then reset and then D in means data in, and then mode. So I'm just use mode. So this is a mode signal. Y means to choose the overlapping or non-overlapping. So if mode high means, if mode equal to 1 means it will do overlapping. If the mode is 1 means it will do overlapping. If it is 0 means non-overlapping. So and then output clock reset D in mode output, and then my output range is D out. So this is my output. So firstly I'm going to register my state by using the parameter S1 S0 equal to 1 or 0, and then I'm just copy this. So 4 state I have. So S1 S2 S1 S2 S3. So these are my first state, second state, third state. So and then I register my another variable here, reg 1 down to 0 current state, C underscore state means current state, and the next state n underscore next is my next state, and then reg, this is for detector. So just now I don't have to use that. So and then now I'm going to write the always block for my for reset condition. Always at passage of clock or neckage of clock. Neckage of reset. So in that, if my FSM in the reset condition, so I'm going to write the condition for that. If my my current state, like so current state, so I can change here state, just confused here, current state, next state. So if reset is, if I means, so it means if my FSM in the reset condition, it will stay in the S0 state, like it will stay in this S0 state. So this is my initial state. So at the reset condition, my FSM state will be stay in the S0 state. Else, if it is not in reset condition, it can do state changing. So current state equal to next state. So this is my default reset condition for my FSM, and then so in the another always block, at any signals triggered means it will execute this block. So inside that I'm going to use case current state. So I'm just checking the current state here. So yesterday we seen, so and then if I'm just assigning the condition for the states in the S0 state. So S0 state, what type doing, so if I take non-overlapping, if it is if a S0 state input is 1 means it will stay in the same state, 0 means it will move to next state, S1 state. So I'm checking D in, so D in is my condition here. If D in is high, I'm checking this. So my next state or a next state equal to, it will check this. If D in is equal to 0, 1 bit binary 0, or you can write 0. If D in is 0 means it will move to next state. Next state is S1 state, or else it will stay in the same state. So if D in is 0 in the S1 state, D in is 0 means it will move to next state. So correctly. So if it is 1 means it will stay in the same state, like a S0 state. So and then Same for remaining 4 state. So here S1, S2. So if D in is in the S1 state, if D in is 1 means it will move to next state. So if D in is 1, it will move to next state. My next state is S2. If it is D in the S1 state, if D in is 0 means it will stay in the same state. So it will stay in the same state S1. So and then if the in the S2 state, if it has input is 1 means it will move to S3 state. So if it is input 1 means it will move to the S3 state. If it is input is 0, so it will move to S0 state, S1 state. Same here, overlapping and non-overlapping, it will move to the S1 state. So if it is 0 means it will move to the S1 state. So here is the problem. In the S3 state, in my final state, I'm creating one begin end here to do my both non-overlapping and overlapping. Here I'm using if condition. If my mode is I'm having one signal, mode signal. If it is high means it will do what it will do. It will do if it is 1 means it will do overlapping. So overlapping. So this overlapping. So if it is D is 0 means it will move to S1 state. If it is D is 1 means it can do S2, it can stay S2 state or also S3 state. So if next state equal to if, so this ternary operators works like a if else only. It is a short form of if else. So if D in equal to I said like a 1. If it is 1 means, let's check what I'm going to write overlapping. So 1 means if it is high means it will do overlapping. So just check here overlapping. If the high means it can stay in the S3 state or also it can stay in the S2 state. So I'm just write here S3 state. If it is in the input of S3 state is 1 means if you do overlapping it will stay in the S3 state only itself, and then if it is 0 means it will move to the S1 state. And so and else so 0. So if mode is 0, so we can easily assign if the mode is 0 means in the S3 state the next state will be, so in the S3 state if using the non-overlapping we must go for, so this is non-overlapping, you must go for initial state. Okay, so it will go for initial state. So my next state here is S0 for non-overlapping. S0 for non-overlapping. So and then let's begin. Defaultly my next state will stay in the S0 state only. So S0 and then end case. So this is my logic of the state changing. So and then inside. So and then I'm using another always block, always at start to uh, to to assign my output. So my output signal is D naught, D out. You can see it, my output signal is D out. So I'm just assigning for that. This end is for begin. So just made mistake here. Begin end, begin end case, begin end here, and then this end is unnecessary. So if reset is high means my D out equal to 0, or else so it's not in state. Else in the S4 state. So my current state is S3 means, so I can use another logic, else if my current state, so current state equal to S4 means, S3 means I can do like a D out equal to 1. So let's check the error and let's check the error here now. So this is a code. So I got 0 error here. You can see here I got 0 error. So let's try to write the test bench to verify the output. So module my module name is TB, so TB, and then end module. So my my signals are reg, clock reset, and then D in, and then mode. So these are my signals, input signals. I'm going to write in reg. My output signal is wire, my wire D out is my output signal wire. So and then I will do instantiation. So my module name is FSM underscore 001. So FSM underscore 0111. This is my module name. So this is my instance name. I'm going to instance state by using this method dollar star sorry dot star. It will automatically connect our uh, Testbench signals and design code signals. So next state equal to d in 1 is where G1 HJ he given some query here. Next state equal to d in equal to 1 s2 and question mark. So I didn't get clearly. So what is your question? Your G1 HJ. So just write here to check my output. So I'm creating my clock always at every 5 nanosecond. I will toggle my clock and then initial begin. So and then I just write my dollar monitor to see my output in the transcript in the log dollar monitor. So just I want to see signals like a d in the binary and then d in mode. So I just want to see mode in binary. And then d in also in binary, and then d out in binary. So mode and then d in and then d out. So these are the things I want to see in my output. So just at the initial stage my reset is high, and then clock is just giving some value for clock, and then my mode is 1. It will do I just give 0 non-overlapping. So I just give some delay 5 nanosecond. How many days in this class has? So in the so after 5 nanosecond I just remove my reset condition for giving 0 for reset, and then mode equal to 0. So and then 5 nanosecond after I am giving some sequence like a d in equal to 0. After 5 nanosecond I am doing another sequence. I just copy this. So here 1 and also here 1 I just give some correct sequence so that it's checking correctly or not. So it will continuously running. Why? Because of I didn't give any dollar finish. So after 20 nanosecond I will finish my stimulus. So I will finish my simulation by using the dollar finish. 0 0 y just given like a 10 delay here. It's this one cycle. Yeah, you can see here I got my output here. So 0 0 1 1, but 8, but I'm getting 1 dot equal to 1 without sequence like a 0 1 1 1. That 1 is missing here. Let's see how it is, how can rectify that. So you can see here my DN is more 0 non-overlapping 0 0 1 1, but here I'm getting 0 here. Let's see how I can get. I'm given like a 0 1 1 1 1, but it will give 0 for third input like a 0 1 1 0. I given like a 0 1 1 1 1 continuous 1, but it's showing like a 0 1 1 0. You can see here 0 1 1 0. Let's change delay here. So here in the first sequence I got my sequence, but it will showing some relay issues. It will show some 0 here, but I got output in the D out 1. You can see here the D out equal to 1. So this is a writing for FSM. So and then I'm going to see like show how FSM work in real time. Yeah, if you take this, so this example code for APP protocol. So this is one protocol, on-chip protocol, to communicate within the IC chip. So if you take a SoC, they are using APP or AXI protocol, and then you can see here they are registering some. They are using constant logic for registering the FSM. So setup, write enable, read enable. So these are the states. So in the AP protocol they are using the 3 state. You can see here they are using the state case here. They are writing the condition for each state, what they are do, what the logic have to perform in the each state. So in the setup state, in the setup state they are doing some actions. So they are performing some condition here, logic here. In the enable state also they are doing some logic here. So in the write enable, read enable, so they are doing some logic here. So this is a usage of FSM. Every code has to based on the FSM only. Firstly they are you can see here. So they are declaring some parameters like logic. So logic, this is a system Verilog code. So they are using logic here, constant logic. So we can't use logic in the Verilog. So system Verilog having the logic, but by using the parameter also we can write the APP code in the Verilog. If you want to declare the states, you can use parameter also, and you can use logic in the system Verilog. So they are using the FSM logic only to write all the code. If you take any code in the or Verilog system Verilog, they are using the FSM. If you take UART, so UART also they are, you can see here local param. It's my, this is a system Verilog parameter declaration local param. So you can see here ideal, this is first state, start bit is the second state, data bit is the third state, stop bit is the fourth state. So by writing the UART code also we are using FSM, but in the different name. So we are giving some name for the each state, like S1, S2, like the same way. So basically sequence detection is a basic thing to write the FSM, to know how FSM work in the real time projects. So I think so we'll get my class FSM Mealy and Murray and how to write the code for that. So this is for today. If you need doubt means you can ask now. We can use also for mode. So I'm using a mode here. By without mode I can write this also. I can write these conditions inside my mode. So this is a query I got from chat box. So this is for today. This is a way of writing FSM. You just know how to declare a register, how to declare the states, and then state changing variables, and then condition in the each states. So it is easy only. If you know this state diagram, we can easily write the FSM code. So this is for today. Thank you for listening. We'll see you tomorrow with new topic. Thank you guys. Thank you for listening.